All right, we're diving into a breakthrough in AI that is, well, it's as counterintuitive as it is brilliant. It's a story about how plain old English, yeah, just regular English, completely outsmarted Python in the race to build truly intelligent machines. But first, let me ask you a question. It's a real head-scratcher. How can a super smart AI absolutely dominate something like the International Math Olympiad, a feat of incredible high-level logic, and then just completely fail at a simple visual puzzle a kid could solve in like 5 seconds? This isn't some made-up scenario. No, this is the central paradox that's been driving AI researchers crazy.
And this right here, this is the test that exposes that massive weakness. It's called the Abstract Reasoning Corpus, or ARC-AGI for short. You can pretty much think of it as an IQ test for machines, and it's designed to do one thing: measure pure, abstract reasoning. You know, the very thing that separates real, human-like intelligence from just being a fancy pattern-matching machine.
So, let's really dig into this gap. First up, AI's big blind spot.
So what is this ARC-AGI test exactly? Well, it's basically a series of these abstract visual puzzles. The AI gets shown a couple of before and after examples, and from just that, it has to figure out the hidden rule and then apply it to solve a brand new puzzle it's never seen before. The key thing here is, it's not about what the AI already knows. It's all about its ability to generalize, to learn on the fly from just a tiny bit of info, a skill that, we humans are naturally amazing at.
And when you look at the performance gap, it is just staggering. A person with average intelligence can breeze through these and get 100%, but the absolute best, most powerful AI models, they hit a wall at around 16%. That isn't just a small difference, right? That is a massive chasm. It shows that these models are incredible at mimicking what they've seen, but they really struggle when faced with something genuinely new.
But that massive gap, it might just be starting to close. Which brings us to our next section, a new high score.
Okay, so this part of the story is great. It's all about intense research, fierce competition, and a classic comeback. Picture this. Late 2024, a researcher named Jeremy Berman hits #1 on the ARC leaderboard. Awesome, right? Well, just 2 weeks later, a new model comes out of nowhere and completely shatters his score. But Berman didn't just throw in the towel. Nope. He went back to the drawing board, and by September 2025, he was back with a brand new method, and he reclaimed that top spot.
And his results weren't just a little better, they were a huge leap forward. He didn't just beat the old record on the first version of the test, getting almost 80%. He also set a new record on ARC v2. And you gotta understand, v2 is a much harder version of this test. But wait, here's the real kicker. The previous record holder, they were spending around $200 in computer power for every single puzzle. Berman's new method, $8.42. That is over 25 times more efficient. So this isn't just about a better score, it's a totally different, fundamentally smarter, and way more elegant approach. So how on earth did he do it?
Well, that's what we're getting into next. Section 3, Survival of the Fittest. Idea.
See, Berman's first attempt, like a lot of others, was to get an AI to write Python code to solve these puzzles. And on the surface, that makes sense, right? Code is logical, it's precise. The problem is, it's also really brittle. The super complex, nuanced patterns you find in the harder puzzles, they were just too tricky to pin down with rigid lines of code. So he did something that sounds completely backwards. He switched to generating instructions in plain English.
He calls his new system evolutionary test time compute. And it works pretty much like a mini survival of the fittest for ideas. Here's how it goes. First, a big AI model comes up with 30 different solution ideas, all written in simple English. Then, a team of little AI subagents tests each one out and gives it a fitness score. The top 5 ideas, they get sent back to be revised and improved. And if that's still not enough, those top 5 get mashed together to create new hybrid solutions, taking the best parts from each. It is literally evolution, but for ideas.
Okay, so the method is brilliant, no doubt. But the real question is, why does it work so much better? That brings us to Section 4, the fused circuit problem. Berman started noticing something really weird about how these AIs were failing. They weren't just getting the answer wrong, they were being, well, profoundly illogical. Like, an AI would claim a shape was symmetrical when you could clearly see it wasn't, and even when you told it, hey, that's wrong, it just couldn't correct itself. He came up with a name for this: dead reasoning zones. These are like little black holes inside the AI's brain, where basic logic just completely falls apart.
And this, right here, is a huge difference between us and them. Berman has this great quote:
Humans have dead knowledge zones, but not dead reasoning zones. Think about it. An economist who learns how to code doesn't suddenly forget how to think logically. They just apply that same core reasoning skill to a new subject. Our ability to reason is totally transferable.
This all comes down to what Berman calls the fused circuit problem, which is the key to understanding why those dead reasoning zones happen. See, current AIs don't learn reasoning as this pure general-purpose skill. Instead, they learn math logic and code logic and writing logic as separate things, all fused together with specific topics. So when you throw a totally new kind of problem at them, like these ARC puzzles, that specialized logic just doesn't transfer over. It's almost like they've over-specialized their thinking to only what they've seen before.
So, where does this leave us? What does all this mean for the future of AI? That's what we'll cover in our last section, Reasoning into the Machine.
I think the biggest takeaway here is this. Just making our AI models bigger and throwing more data at them probably isn't the path to true artificial general intelligence. Berman's success proves that the real breakthrough isn't about size, it's about the method. His evolutionary approach shows that if we want to build truly general intelligence, we have to completely rethink how these models learn to reason in the first place.
And this leads to a final, really powerful idea. Maybe the goal isn't to build an AI that can magically think about stuff it's never seen. Maybe the real goal is to make reasoning itself a core part of its training, to actually teach it the pure, abstract, transferable skill of logic, the same kind of logic that we humans use every single day.
Berman's whole evolutionary approach, using plain English, feels like a massive step in that direction. And it leaves all of us with a really fascinating question to think about. If we can actually teach an AI to reason with the same flexibility and power as a human, what are the next big problems it could help us solve?